Hello, everyone. Welcome to everybody who is joining this info session and everybody who is watching the recording after the info session. Um, as you all know, this is part of the info session series that we're bringing to you as part of the Africa Deep Tech Challenge 2025, where we are encouraging you to come up with your awesome and innovative ideas around resource constrained computing. As you also know, one of the key things in this challenge that is required to make a great submission for this challenge is your project report or the documentation that follows your project. In addition to the fields that you fill out when you make your submission, you're also required to have a full project report or full project documentation of whatever it is you built, whether it's hardware, software, combination of hardware and software, whatever it is, we're expecting to have a full project report. And that is why we feel documentation is really, really important. It's an important aspect of this challenge. And this is why we are very, very happy and elated and proud to have with us no other than a Guinness World Record holder, Oluwatobi Oyonlola, with us to talk to us about how to document your hardware projects or projects that have a hardware component. As you may already know or you may have heard, currently holds the Guinness Book World Record of for the smallest ever GPS device. The smallest ever GPS device. That's really, really awesome. And so you would imagine that he would know one or two things about how to document your work. And so without wasting any more time, I'm going to hand off to Oluwatobi. After his presentation, there's going to be a Q&A, ask me anything session where we'll take questions about documentation, hardware documentation, IoT, Oluwatobi and his background, and the contest in general, right? So keep your questions ready, and if you're watching the recording and you have questions, you can put them in the comments, and we'll be sure to get you the answers. So without wasting any more time, here is Oluwatobi. Thank you so much.
One of the projects we worked on that I led the firmware and also the circuit design for this project, and we have some other colleagues that also work on the what's it called, data calibration. We have a PhD student postdoc that work on the data calibration. He also lead the paper that we have to publish for this because in a research field, uh, publication is one of it's like a currency that you have to use for your career ladder in the field. So the project is Flatburn. Why we call it Flatburn is still unclear, but I think my PI was in Lagos in 2022. He has never been to Lagos, so we're inside the car. And when they show the design of the project, it looks flat. And from the previous project we've been working on, we've always used black bond, something bond. You just say, oh, this looks flat. Let's call it flat bond. So everything about the project from A to B, A to Z, it's inside the GitHub. It's public, and you can see we had like different people watching, and I don't know if people actually built something with this, but at least we can see that it got so much kind of attention within the engineering space, people that are building things that has to do with environmental science. So the goal for the Flatburn project is that in generally speaking, you've seen different places whereby they install stationary sensor. And stationary sensor on the good, they only just capture within a radius of a space where it's been deployed. In my lab, we started this new idea, like new innovation, whereby we thought if we put a sensor on top of vehicles, we can actually capture data within a city block by block. Imagine you have a sensor, a very expensive sensor, install it in just one stationary position. It doesn't go more than that. You can receive data. Imagine you install it in Oworoshoki in Lagos, for example. There's no way that sensor would get data from, even let's say Bega, as if you're going to Ogun State. There's no way. But if a sensor is mounted on top of a vehicle in Oworoshoki and it moves across that street and keep going in a specific, speed, you will keep sampling data as you move around. And based on some machine learning that we developed, we're able to kind of estimates emission based on as the vehicle moves across, that region. So that was actually the innovation behind it. We've published like several papers. I'm also part of the co-author of some of these papers as well. But when I joined, one of key thing I wanted to do is this has been going on for 3 years before I joined the lab. Can we try to make it completely open source so that my thought was developers in Nigeria, developers in Africa can actually go on this website or go on the GitHub and copy the code, use the code, get the circuit design because it looked complex, but I think it's open source. The file that you can actually put inside your own personal computer and just edit, remove some components and do it yourself, it's also there. So that was my mission, and eventually it happens. But they said, "Can you document? Can you make it out there for people to use? Is it possible?" And then I started working on this, and this has been deployed in different city. This was 2022, and over the years, we always try to modify and edit the GitHub itself. So part of it depends on people use GitHub, people use GitLab. You could use different method that you decide, like you prefer. But I think over time, I've seen more community developers, engineers use, GitHub because you can actually Git from your VS Code. I don't know if GitLab can do that. Maybe you can, but you can just log in through your VS Code. Anything you edit, you can push from your VS Code directly without you going to the GitHub websites to do all the addition, like adding things. So, and one of the things I'm showing here is what exactly does the document, if you just read through here, you don't need to even go into each of these files, folder one after the other. By you reading through everything, from those words, what does it mean? So for example, build. This has all the files required for you to build a full-fledged flat bond. So including the 3D model, the electronics, and also the firmware, because that's exactly what you need. So after you're done building, you're looking for, okay, how do you now explore? How do you explore some of the data we've collected with this device? You need to look at the data set. And then if you've collected the data, how do you calibrate the data? So we also we have this calibration handbook. So from just the homepage of the GitHub, you can easily navigate into each of the, folder here without, just click on it and it takes you to the folder. You can easily go inside and do whatever you want, either edit and copy and do all sort of things. So that's why we try to document that. So it has the hardware. What does hardware entails? It entails the fabrication file. So by the time you decide that you want to build something, you want to prototype something by just going on the public website like SparkFun, or if you're in Nigeria like Microscale, or in the US, there's Adafruit, there's SparkFun, there's DigiKey, Mouse, different companies. You could source component there, design your circuits, create a file. You could use different file, different software rather. It depends on what you can afford. There's open source tools for circuit design as well. So you don't have to actually buy, there's Altios that I don't know how much they're paying now. There are some other expensive software tools that you can use depending on if you're in the educational sector, maybe you can get it for free or get it for 6 months usage that you can just use for your design. So basically, you need your fabrication files. If you're doing the 3D printing, you have the hardware schematic. And what we try to describe here is the .brb means if you download this file and you open your key card or you open some of your files, you can actually, install it directly. So, the cadence is expensive. I don't even know how much they are doing it now, but because of the research that we are doing, we had partners and collaborators from Cadence, and we're able to get it for free. But what we try to also do is, which we're still going to release in not near future, but very soon. We've converted some of the schematic into different open source tools as well that people can use. But this alone, if you download it and use the free version for Cadence, you can actually edit and do everything you want. And for the firmware, which I wrote everything from the beginning to the end, and of course the circuit design as well. But I was more because the firmware kind of tied also to the code exercise. It ties into the calibration because what do you want to calibrate if you don't know the kind of data that is coming out of the device? So, and the payload means payload going back to the electrical engineering parts. It means what are the data that is coming out from the device? Meaning temperature, humidity. Um, we have the GPS also. We have, SPS, particulate matter. We have gases. So these are kind of parameters that come out of the device. We also have different other important data that comes out of the device. Like you want to know, is the device charging? How long is it charging for? How long will the device last for? Everything is actually part of the firmware itself. So if you download this firmware today and you put it inside your VS Code by following the instruction by Particle, because we use the company called particle.io. Uh, just 1 second, let me see comments just to be sure that uh, something is not going wrong because I'm already in the spirit. Okay. Okay, cool. So yeah, so Particle is one of the company that they've designed system in a module kind of a platform whereby you don't actually need to buy any SIM card. It has its own SIM card. It has its own microprocessor. They give you a dashboard. Within the dashboard, they actually created different libraries and different information um, within the platform itself. So we use the particle because it's very easy for us to quickly build and experiment. So the firmware is there. So handbook also gives you like the guide if you need to follow each step after the other to make sure that if anyone is going to pick this up and do it themselves, they do the same method. So what is the first thing I need to pick? Oh, after printing, I need to pick a cable. What kind of cable? Excuse me. What's the size? What's the measurement? What's the name of the cable? I need to pick screws. What kind of screws? Different information about what you need for the fabrication itself. So, and that's the build and explore. I've explained that we have the data set from some of the cities we've collected data from. A coding exercise also, if you're a computer scientist or you have some skills in AI as well, and you want to kind of understand the data coming out of this, you want to run some sort of scenario basically. So, for example, we have GPS data. Don't forget the device is going on top of a car. It could be, in fact, what we've done in some of our pilots is that we deploy this in on top of what's it called, trash vehicles that pick up trash in neighborhood, and we know for sure that these devices will go into those neighborhood every like once in every 2 weeks. So imagine if it's doing that cycle for like a month. We'll see pattern of, oh, Mondays to Fridays, something that there's a little bit of emission within this area. So that's one of the reasons why GPS is important, and our innovation is also important because we capture block by block. We capture, when I say block by block, meaning street level by street level, basically. So coding exercise will give you like a specific how the device has been moving. You can edit that. You can also compare. You can add that data. Um, can you give me 1 minute? Just one sec.
Good.
Yeah, yeah, yeah. Someone is just knocking at the door. Just
All right.
apologies.
Yes. Well, that was so far this is exceeding our expectations. So we'll just give Oluwatobi a minute to come back. In the meantime, like I said, anybody who has questions, please put it in the chat or in the Q&A.
Okay.
Okay, welcome back.
Yeah, apologies.
All
I
good.
I try to make everyone go away when I'm doing it, but they still want to disturb. So yeah, pretty much. So we have the learning part. I was explaining that. So the coding exercise will give you the activities you need after capturing the data. So you can actually use this for presenting your data if you want to show it to the government. If you want to edit the code base itself by just adjusting it and say, oh, you want to only see data capture within a specific region. You also want to capture. You want to combine data from the expensive sensors, because what we've designed is actually cheap sensor. When I say cheap, also, if you compare the expensive version of this device that costs like $40,000, and this costs almost like $2,000. But in the field of environmental sensing, this is still categorized as a low-cost sensing platform. So for the coding exercise with the Jupyter that we also created, you can actually add data points from those expensive sensor. If the city provided the data and the API is also online, you can actually add this within the Jupyter notebook. So what we also added is the handbook, because what we realize is that we have to always go out to different cities to present, to give this device to citizens and developers to build. So we've created a facilitator handbook whereby if we are presenting, these are the information that will show that the device is working well. If they are also deploying this device, they would see all the parameters that the device is supposed to print out. So imagine you go to a city like Boston that during when it's cold, it's always sometimes minus 10. And then you deploy the device outside that is supposed to give you minus 10 degrees Celsius and it's showing like 20. So definitely something is wrong. That's a very inaccurate reading from the temperature sensor itself. So yeah, pretty much that is that about the flat bond. You can go on the website. We also have a web very because my lab we're very good with visualization. So we try to so meaning when I say we're good with I didn't design these. So we have developers, we call them visualization experts. So they are also researchers, or maybe they had PhD in, I don't know, computer science or something. So that's what they do. They just help us. They turn our research project into what it's, people can understand. So this is Flatbond. I'm just going through the website to see it goes on. We empower community around the world to monitor their environmental sensor. And then it shows the 3D model as you build on top. You could have some question, how do you get power? It has solar panel. What is under is a magnet. So it's a very strong magnet that actually, if you put it on top of the car, it's going to stay there. They have, we've had experience of hurricane in the US whereby this system still stand the test of that particular wind environment. So, and then it goes on it shows these are some of the electronics PCB inside as we clutter. Even if you go through the website alone, it gives you some sense of what do you need to put together before you deploy it. So it goes on, you put the PCB, you put the gas, you cover it, and then within the website, each of these, if you click, it takes you straight into the GitHub. So if you click on the overview, that's the first page of the GitHub, the hardware, the firmware, the fabrication, it takes you straight to GitHub as well. So so there's a question that probably we can answer later. I just keep going. So we've done deployment in different places. This visualization is not open source, unfortunately. I think because probably it was hosted, yeah, because of MIT privacy and all those things. But we've done deployment in all these dots over. Yeah, the Lagos part was not really deployed for a very long time. I was in Lagos. I was there with the device. I collected data for a few months, like December 2022, and that was it, just to test the device. But the good thing is, before we reach that open source category, you can see the project has been done. It started off in 2017. The first version is just messy. And that's the thing with hardware. Your first prototype doesn't need to look beautiful. It is as you progress in your hardware journey, as you begin to understand what you're building, eventually you realize that, oh, you don't need this. You've learned so much, you need to add this, you need to add this. And as you keep working on your projects, you keep learning more, you keep discovering new things. For example, the first version was just pipe, meaning the goal is let's attach things together. We want to like it has magnet, but this very small version of the magnet. But the goal is you want to use temperature sensor, get a module, put it there. You need a CPU or a microcontroller, attach it. That alone will work. Do you need extra sensor? Attach it. That was the first version. And then as it progressed, they felt, oh, how do we power this? We need solar energy. Okay, in 2018, they added solar. And it goes on and on. You can see the progress in the design iteration before it turns to this, which we've done in Beirut and Amsterdam. So yeah, and there's also another version that would come up after this as well. That hopefully we can launch that. If you keep going on the GitHub, maybe in the next 2 months, you will see another version. The same design, sorry, not the same design, the same firmware, the same a little bit of different PCB, but it's still more like the same contribution. So we have all the materials, we have people that worked on it, research members, we have publications, we have sponsors as well. So pretty much that's it about the Flatbond. If you go back to the GitHub, the build that I mentioned, you go inside the firmware, it shows that what do you need to do before you start? How do you set up your environment? This is if anyone wants to do it themselves. You need to install the plugin on VS Code. For the firmware, which is also one of the interesting parts for me, is for each firmware we had to add some classes. So you can decide that you want to change the name of the class based on your skill sets, but we've created this to simplify everything for us and also for developers. So for example, if you go into the CD scanner class, this is exactly where what is running the code every single day. We added the motions because the device has accelerometer. So meaning, think about it. The solar panel definitely technically is not enough to power the device for throughout the day, because it's a very small 5 watts solar panel. But again, how do we now conserve energy? It has battery inside. So if the device is moving, there's a traffic light. Sometimes in the US, you have to wait for a few seconds. You've stayed there for like, 20 seconds. Sometimes you just want the device to go to sleep. That's one example, but you don't have to, because even waking up could also drain a little bit of harm from the device. But the motion itself is useful when you put this device in a taxi that they don't understand what this device does. They don't know. Did you just tell them, oh, I'm going to give you 1,000 naira? Just an example. Keep driving this device for 1 month, just a scenario. Um, if they keep going, they don't care about it because they don't know. They don't know what is coming out of the device. So imagine they go home, they are not supposed to retrieve the device, they leave it there. You want the device to go to sleep just to preserve energy, and that's exactly what the motion is doing. So we have different operation mode. It logs data into the SD card. There's an SD card inside. You could also stream data over over the cloud. It also has communication over LTE-M depending on the country. If you're deploying it in the US, we have the LTE-M whereby we can deploy using the LTE-M network. If you're deploying in Europe or in Africa, it also has the 2G and 3G that you can also use to stream data over the network. So pretty much those are some of and you can see we put for the firmware, this is the README for the firmware that is also important if you're documenting your project for the competition. And really, generally, if you want to keep working on anything that has to do with firmware or hardware, it's important that as you document, as you also read, you kind of understand what you're doing, and you can present it to people. Um, if you get investors that want to support you, they want to see what have you actually done so far. How can we trust that you've built anything at all? What is the proof? How do you show us what kind of data is coming out of the device? These are things that it will be helpful for you to have as documentation to show. So pretty much that's that about Flatburn. We have the command line. So imagine because from the particle, don't forget the particle.io, there's a CLI whereby if you connect to it, you can actually send some command. So we have this command as well that we can use to do anything. For example, we could dump data. We have the SD card, SD dump. We could dump all the data inside the SD card. We could also do device check. So meaning you put this device on top of a downfall car that goes across Lagos. You don't know if they've actually someone Agbero or something. Someone took off the device. If you use this device check, so far they don't know what this device. They could think, oh, this is a magic or whatever. You can actually run the device check. It gives you the location, the specific lat and log, and potentially the goal is you can go there and retrieve it, and maybe you have to pay them or somehow. Because what we've experienced is no one actually stole this device ever. Because from the previous iteration, we try to make it really look ugly, and then it turns to be beautiful later on. So if anyone see, be like, what is this? So they decide not to even touch it. It doesn't have any lights that it's so fancy. If anyone deploy a device and you put different lights and just blinking, they'll be like, what is this? It must be very expensive. We decide not to put any lights for it to kind of give attention. But if you open it up, we have indication that shows, oh, the device is charging, the device is connected to the internet, different things as well. So I love this project because I know in and out of it. We've done more projects that it's not public, but we have it on the GitHub. So we decided not to make it public because of some of the proprietaries of some partners that we work with. So I will start from Flatbone. We have the hardware, which shows the enclosure, what do you need, and the bill of material. You can imagine, we try to show some pictures as well. We have the step file. If you copy this, you can print directly. We have the schematic as well that shows the bill of materials, everything you need, circuit diagram and everything you can download and build it yourself. So that is that about that. And you've seen the website as well. Excuse me, you can spend time to understand. And, I'll be more than happy to, if I have feedback and say, oh, is there any source file? What are the method was used for the development of this website? Go on, like if you go on the lab's website itself, everything, any project that we deploy in the lab, it comes with a website, and that's MIT for you. Any project is always there's always this very way to showcase it that it's great, and before you can showcase it, you need to put it on some sort of website or visualization that people can learn and read and understand. In anything, there's no way the project is so scientific. For example, one of the very projects in the lab that is, I think, fiber space or something. It's so technical, and we still have to develop a website, a visualization for it that has some sort of video and everything to show the project basically. So yeah. So back to still documenting. So back in 2020, 2021, so there was a competition. I love competition. I wish I can also apply. Chukwemeka, can you open it to everyone to apply? I'll just apply and also, also get involved. Um, so back in 2021, during COVID, I also kind of got involved. I've done competitions almost all the time. So this was Arcade. So there's a website called Arcade whereby they raise a call that people should come up with. It's a competition that people should apply, and I apply. They have to set up a team. I didn't know. So all my team members, I don't even know them. We've never even met till date. But the goal was that we all apply. Um, Based on our CV and based on some of the things we've done, they would just select and just match us together. So Erin was a mechanical person. I do electronics and firmware. Leo also do electronics and firmware. So they could just match us together. But there's a company that was really interested in conservation. So the company is Conservation X Lab. So we had to develop some sort of it's like a robot that goes inside the water that deploy that helps tangles or untangles kind of buoying within the sea. So that was pretty much what they're trying to do. We did it 2020, 2021. And I think they kind of like extended for like additional 6 months. So this website also shows because we have every week we have to document. You can see how many components, sorry, the logs that we have. So 79 logs. Logs mean how do you upload all the time? So that, it shows that every now and then we have to have something to write. For example, what works, um, what doesn't work, the failure, the success. Of course, what most people usually write is always the failure because before you can reach the success, probably towards the end. But we had to document everything, including with the meetings, everything. And we also have the files for the project as well. Everything documented. We try to create the problem solutions, and we go on different prototype before. These are some different version of the prototype itself. So Arcade is also, I'm just using this as an example. If you go to arcade.io, you can literally just create your own projects, but they usually have callings of competitions or different calls for people to come up with projects as well. So Arcade is also a great place to document your project. You can imagine a lot of people actually view this. I love this website that at least it could show how many views you had. I mean, for GitHub, it will only show who fork it, who get into it, who kind of start it, or and you could also get comments from Arcade as well. Sorry, from GitHub as well. So that is Adway.io. So pretty much these are the two major, at least, that I've tried to make public of what I've worked on. I still have some other private ones that I've contributed a lot that maybe it's on my GitHub, but some are not public. But you don't have to make your project public, but documenting is really important, and the step by step that you can use to kind of document. So I don't know if there's any questions so far. If not, I could move on. So part of the things I also want to show today is if you document your project, you're good with it. Sorry. And then you want to potentially get a certificate for it. So I'm part of Open Source Hardware Association. So Oshwa created, let me start from here. So Oshwa is known for, for a few years now, whereby anyone building hardware, how do we support, how do we provide the necessary step-by-step for you to actually document, get your project, like following the rules of Oshwa. If you follow rules of Oshwa, your project is already following the rules of open source. It's also following the rules of documentation. So we created the certification whereby if you apply, you submit, or imagine you have your GitHub ready and you want to make it out there. See, one of the reasons why I love open source, and when I say I love open source, is that we've all benefited from open source. We either, some of us go on GitHub, copy a library. We use a lot of libraries that some other people develop. So the only thing we can do back to that community is to give back. So how do we give back? If you came up with something really unique to you, or you kind of develop a library for computer vision or for reading I2C or for something different, and you decide that this would be beneficiary to the community, give back to the community. You took a lot from the I also, I'm not I every single day I search GitHub, search specific library, download, copy. You can give reference if you're also if you're trying to use the same library for an open source project. So you have to kind of link it to their project as well. So Open Source Hardware Association, I'm part of the board member. We have there's a process to kind of get something like this. You can get a code number, you can get an ID that you can print and just attach to your project. And if you're able to do this, there are a lot of benefit that comes with it. For example, OSHWA has a very, very important Twitter network whereby they can share your project with the community and people can actually go on to the website and kind of download and learn more, ask questions. You can put your code into Arduino library as well. I've done that as well with one of our projects in the lab. So certification could also be great, but it's not the goal for the competition. But I think it's something to be aware of that you can actually kind of think about if it's something you want to do to the community, you want to contribute to the community. But what is really important, why I'm sharing this, is that if you follow through OSHWA certification process, that means if you get it approved, that means you had a very fantastic documentation already. Your GitHub needs. So, and one of the things we can also kind of approve is if you have some hardware, your code base is well structured, and your documentation, meaning the design files, everything is there. So it's very simple. If you click on Get Started, it takes you to some information about Hoshua in general, and you learn more about it. I think I have another page. Yeah, this particular shows step by step that you can, fill in within 2 weeks. You get a response from Oshwa if it's approved. If there's any question about what are the things you need to do or you need to edit this. But if you're able to do the certification as well, your name will be listed here as part of the project that got into Oshwa, like Oshwa certification. Oshwa in itself is not a small organization. It's an open source organization. It's non-profit. Uh, we've got we've got funding from the U.S. government, like NSF, almost like $1 million to support projects in research, support different projects that has this open source element. But we have to distribute. It's not our money. We have to distribute like 50K for professors in different universities. I was also involved to kind of check out those projects to get it approved. But if you have your OSHWA certificate and you get it approved with OSHWA, your project also will be listed here with some sort of UID that you can kind of reference if you're writing a paper, if you're sharing it with friends. This is a typical example of a project on OSHWA website. It tells you the dates, the country that got certified. It also, if you click on this, it takes you to the GitHub and that's it. And the person can keep updating. This was 2 years ago. The person can keep updating different version, you know. And within that GitHub, it also shows like, oh, you have this particular number, very unique Oshua number as well. So I just share this because Oshua is really great way to learn how you can follow the checklist if you don't want to follow the flat one that I created for the lab that I just shared before. But Oshua is a very fantastic way to also kind of checklist everything you have to do. Um, so back to, let me see. So this is the Oshawa website itself. It's we still in Africa we need to fill this session as well, but we have people from Egypt, we have people from Saudi Arabia, which is outside Africa, but at least we have two projects from Egypt. So guys, if you want to fill up this map, it will be great. I'm not this is not an advertisement, but I think it will be nice. We have projects from the US, from every part of the world, but let's contribute back to where we took things from. It's like giving back to the community. So it will be really beneficiary to the community as well. So yeah, this is also our website. We have like different team and uh, yeah, different collaborators. This is the director. The husband. The husband is the owner of Spark Fund. Spark Fund in general is open source. Anything if you go on Spark Fund websites, you try to buy components. Any component you are buying from Spark Fund, there's a file, there's free PCB, free document to print it yourself. So I'm happy to be part of the board member. We have different members. This guy is working with Tesla. So we have different people that are contributing to curate this platform for betterment of it to the world. This is also a professor in one of the universities. So yeah, and that is Oshua. Now, if you now decide to sell if you make it open source or you documented it, or even if it's not open source yet, you want to sell some of your hardware. There's also an open source hardware, I don't know if I should call it sales website. So it's called Tindy, whereby you develop something. You can see all these projects I just showed. It doesn't look like a company. It's just one man mopo. We used to use that terminology in Nigeria. It's just one person that decided to create something and wants to sell it online. And it looks expensive, but I've ordered something here as well. So Tindy gives you opportunity to sell your open source or well documented hardware projects. So you created something unique, like this guy created Nano VNA. It doesn't have any VC or all this funding, but he still want to sell it. Do you think people want to buy it? He posted it. He can post it on Tindy, and people can place an order. And what that means is, uh, any part of the world, you're ready to sell this. You can be in Nigeria, you can be in Ghana, you can be in any part of Africa, they can place an order. So far, it's documented on GitHub. You put it there, they order it, and they can use the device once they go back to the documentation you created. So this is just a typical example. It shows all the pictures, it shows the spec, um, and it shows you have to describe some of the information about the device as well. So Tindy is also one place you can. I mean, if you need some open source and like you want to support open source as well, you can also go to the website and buy your project there as well. Other two that I also want to mention. This is more for, it's like a Kickstarter for hardware. So Kickstarter is very huge platform. Kickstarter is meant for really, I mean, you could raise like $1 million or whatever. Uh, but for someone in our own field, like hardware developers, we're just one of two or three people working on this. We don't have all the publicity. Kickstarter, you have to apply. Um, Crowdsource is also an open source, low kind of small volume kind of platform. It's like supporting other developers as well. So you can also put your project on crowd supply, whereby you get people to support this to get it to live, for you to actually develop it further. Basically, you can see this one typical example. It's open source. It shows that there's a maker behind it, and maker means they're explaining everything. You can see this guy saying, "Oh, GPIO pins." Definitely, these are people that are building things themselves, like really developing things. I mean, Kickstarter is great, but you need extra hands from people have to do a video for you. They have to do a lot of things. It's a lot of process for Kickstarter. But crowdsource, if it doesn't look beautiful, you can still put it there. So yeah, you can, if you want to create a campaign around your project, crowd supply is also like a very interesting platform to do that. Um, Another one is group get. I've used this as well to order some components just recently. So the group get is very close and similar to crowd supply. So you can also go on group get to, I don't know if they ship anything to Nigeria or to Africa, but at least if you have a project that documentation is clean, maybe you get an OSHA certification for it, and you decide to put this on GroupGet as well, you can put it there and it can reach more people basically. That's also the goal. Not just yourself or within your country or continent. You want to push this further to every part of the world because you, in your own expect, like you think this is great and people should be involved in it. One of the very interesting project that I think they are now in, they started probably on GroupGet, but they've moved to Kickstarter. It's open something. OpenMV. Yes, OpenMV. That's the company. They try to design device that you can use some sort of flare lepton, which is a thermal sensor that could say temperature gradient. They use this during COVID. This is just the sensor they use. But they've moved to Kickstarter, but everything they've developed is completely open source as well. So pretty much these are one of the things I wanted to share. I don't know if there's any question, but it's the same. GitHub is one of the very first thing that you have to kind of start from. And then if you develop further from there, you keep writing your code inside, keep editing, keep kind of building within the GitHub space. You can do whatever you want with your hardware. Basically, you can sell, you can share, you can make it go viral, you can do whatever, basically. So yeah. So I'm gonna pause here and happy to get questions and feedback as well. So yeah.
All right. Thanks so much, Toby. This has been great. Uh, we have a few questions.
Okay.
Um, and I'll say, folks, use the Q&A to ask your questions, and we'll answer them. Your questions can be honestly about anything. It's like we're now in Ask Me
Very, yeah.
Anything mode, right? So you can ask about what Oluwatobi talked about, anything around documentation. You can ask about the project. You can ask about hardware, software integrate, anything. I even have
Yeah.
some questions.
Okay.
And you can also ask about the innovation challenge itself, because I know
Yeah.
some of you may be hearing about it for the first time. Maybe I'll even take, let me just do this. Let me just flash this on the screen real quick. Um, just to inspire folks. So for those of us who are joining for the first time or seeing this for the first time, this info session is uh, part of the Africa Deep Tech Challenge 2025. The theme is resource constrained computing, and we're looking for folks who can build anything, breakthrough tech that thrives under resource constraints, hardware, software constraints. That's really what we're looking to you to do. There's 20,000, there's more than $20,000 in equity-free grants. There's mentorship, there's investor access available for folks who do well in this challenge. There's a link there we'll put in the chat. And there is no boundaries in terms of the theme, like agriculture, fintech, health, smart cities, hardware, software. We're allowing your creativity to shape what this is all about. And it's powered by Future Africa with IHS, which is one of the top infrastructure companies in the region, a Learning Innovation Hub, Co-Creation Hub, the 3MTT program, the Distinguished Ambassadors. These are community partners. We have Kala, we have the Omniverse, we have ARVR Africa, we have GDG Lagos, ISN Hubs, Web3 Africa, a bunch of very awesome partners who are working with us on this, and a very formidable judging panel. So the deadline for submissions is July 31st. and we'll go into different rounds. All the information you need is in the link, the bit.ly link, which we're going to share in the chat as well. So, don't miss this in case you're still considering. And that's why we had, Toby join us because, documentation is a key part of this challenge. You can build all the awesome stuff in the world, but if you don't document it properly, nobody's going to be able to know what you built, right?
Yeah.
So, this is a very important session. So, you can ask any question about
So
anything, documentation, hardware, or whatever.
yeah, I'm also looking at the questions on the Q&A.
Mhm.
Um, what can you consider as MVP for monitoring system, especially if this innovation depends on both hardware and software components? What do you want to monitor? Is it energy? Because I think part of the challenge is probably energy monitoring something, right? Chukwemeka.
Yes. And yes, energy is a huge part of it.
Okay.
There's a
So maybe
category
that's what you.
actually. There's a category for folks who are doing projects in energy where you stand to win an extra 4,000 if
Okay.
you're judged to be the best. Yes.
Yeah. So I don't know, like, it depends on your skills. Like Yusuf Yaya was asking about the MVP for monitoring. So what I would suggest is what do you want to monitor? Electricity, okay. Is it you want to just monitor the current that is coming from your gadget, or you want to monitor the energy use? You have to specify. So I'm pretty sure one of the things you have to start from is your current sensor, because current sensor would actually help you to monitor your energy use based on what the device is drawing at home, or what the device is drawing from the entire household, basically. So for example, you have a junction box, just a typical example, and you want to monitor a specific room. You put a clamp current sensor across it, you power the device. So what do you want to power? So when I'm saying MVP, meaning it's difficult. You have to kind of pick different things. So if you want to start from, oh, you want to get Raspberry Pi, you want to get the Raspberry Pi to connect to the internet. Do you have your own router? Do you want to make Raspberry Pi? You just use the IP address to get connected, and then the GPR pin from the Raspberry Pi, you can connect it to a different board, and that different board could be a current sensor that has, I2C, meaning I2C is just an easy way to you can plug anything like a prototype. And they've created like a quick board whereby you connect your current sensor to Raspberry Pi, and within Raspberry Pi, connect it to your computer, like a screen, like a normal TV, uh, and go to Python, go on any website, do a little bit of research, copy one simple code, read the current sensor values. Was able to do that, for sure, if you plug a computer, you can estimate that this is a computer, because computer will draw a specific rate of ampere. If you plug a phone, which is just a charger, it doesn't consume so much. You can do all those differences from like just your table setup. Because your Raspberry Pi is connected to the internet, you can set up some sort of Node-RED. There's a website which is open source called Node-RED. You can set up a pipeline whereby you want your data that comes from the current information, like current sensor, to the Raspberry Pi to go to a specific IP address, and the IP address could be hosted within Raspberry Pi. So localhost something something, and you just visualize it. This can be done in a day if you have all the components on your table, to be honest. So that means you don't have to really solder anything, because Raspberry Pi, it's a small computer unit on its own, but it gives you GPIO pins that you cannot just plug to your sockets. You're going to blow it up. So you need a device that connects using some sort of GPIO pins, like 3 volts or some sort of logic, that you can connect to Raspberry Pi, run your code, and get started with that. So that's if you want to just know your energy use, you want to get information about the consumption and all those things. But if you want to go further and say, oh, once the current from this particular socket go above this, shut it down. So you need to now introduce some sort of relay if you want, and you can also buy a relay that is a module. you connect it to it, and So yeah, these are just like going telling you like practical things that you can do to just get it done in a day if you have all the components on your table. So that's one with Yaya. I don't know. Yaya raised his hand. I don't know if he wants to speak directly or it's just. But I will go forward
I
with
Yeah, I asked him to put any clarification in the comments. That might be faster since so far we have 7 questions, and I'm sure
Yeah,
there's
and I'm trying to go through one. Yeah.
yeah.
So there is open source for yeah, as I said, KeyCard is open source, which is it's the as I said, the next version we're creating for the GitHub that I shared is going to be completely KeyCard. I have the files. I can also potentially once that is out, we can share that with you. But we because the way research work, you always get support from some specific company, and because you get support for your research, they say, oh, you have to use their tools, and that's one of the reasons why we use Cadence. For the world record that I created, it's all developed with KeyCard. It's not open source for now, but let's see if I get motivation to make it open source. But at least because think about it. If you want to send your files to production, like for example, JLC PCB or PCB, these are companies that produce PCB in China. One of the files they request for you is very like the same format like KeyCard. So yeah, that's one. That's KeyCard is one of the like very easy tools that you can also develop your own library for it. There's a script like batching that you can use to create your library for KeyCard as well. So you're asking as a student, yeah. You also ask that platform versus Zephyr. So depends on your level. Are you a PhD student? Because if you're a PhD student, maybe you've done some basic with platform.io and you want to just expand. Because Zephyr itself is a little bit complex, meaning Nordic Semiconductor are using it for developing Bluetooth communication. I'm sure Apple has their home proprietary from Zephyr that they get from Zephyr. Zephyr is open source. FreeRTOS is also open source. Platform is very close to Arduino based on the syntax of the code you're writing. So if you're writing plain C, uh, it might not completely work. If you're writing Arduino C++, because it's not the same, it's going to work. So platform is also very close. If you copy any code from Arduino, there's every tendency that you only need to do some little bit of adjustment and it's going to work on platform IO. So, but yeah, that's the only difference. But Zephyr and FreeRTOS, it's a little bit advanced based on what is your level of experience in hardware in general. So if you want to blink LED today, lines of code you need is probably like 7 basically. But for other Zephyr that you mentioned, you need multiple things. You need to declare different pins and all those things. So um, regards to GitHub, we can actually get a wrap up on how to build hardware projects using Git. So GitHub won't give you how to build hardware. It's just give you how to document your project. So you still need to you need to use some other tools that we just mentioned, which is KiCad to design, develop, create, and do all sort of things. Um, so, and then once you're done, you can extract the file, put it inside GitHub. Because the GitHub I also share, it's the lab's GitHub. I would have loved to, show step by step file, create it, but it's going to take, forever to do that during the course. So, but yeah, it seems like the project, yeah, it's combination. It's hardware, firmware, software, and also 3D modelings and design. So that's what we have for the that I kind of presented. Yeah. Um, so yeah, it has firmware, it has hardware. The hardware has the enclosure, which is the 3D model that you need to print if you have a printer. So why talking about deep tech, applying the technology? Yeah, so I answered this. Um, Applying the technology in the news field based on the resource constraint pool, does it count, or are we going to build a woods? Please don't build. Even myself, I have Nano, MIT Nano, very close to me. I cannot build a new sensor, so don't try yet. You can do it if you have experience, but it's just a. I think last week that Ola was talking about chipset design, so you should talk to Ola if you want to develop a new sensor. So maybe you can help, but it's a very expensive process. For the competition, please, you could go do whatever you want, but I won't encourage you to design a new sensor because think think about the temperature itself, temperature sensor that costs, I don't know, $5, depending on what you're buying. It's a semiconductor. Before it can actually print out the data that it's useful, it goes through a lot of calibrations, and this calibration cannot be done in Ibadan. Or, I mean, why I'm saying Ibadan is I was born there, so you need a very expensive factory to do the calibration to kind of test it to give you the result that you want. So I won't encourage you to build the whole sensor. I will encourage you to buy the ones that are already in the market, like a module that would, you can just connect to your product or your project that you can just get the data out and you move on. But if you now reach a stage in your research or your career and you have opportunity to actually build all those sensor itself, you have fabrication labs that whereby you can build your sensor, then go for it. So um, and then, so that's that. And Carl will also say, please, is there any tool recommended for hardware simulation? So, that transfer data over the internet. Yeah, that might be. So, hardware in general. So, it's difficult to simulate a real-time hardware whereby you put data into it and you see the results. Because it's hardware, you need physical components to put them together. Um, but there is Proteus that I used like way back. It gives you can write your code, meaning Proteus is a company like I think Lab Center, something, that's the name of the company. So you can write your code. They have like a very huge environment whereby for the microcontroller, if you select the microcontroller, you can write your code somewhere else. You get the X file or ELF file for simulation. You can drag the ELF file into the chipset that you want to use, connect LED, connect everything to it, and you can get it simulated. So yeah, so that's the only simulation. But if you simulate with Proteus, doesn't mean it's going to work in the real world, because in real world you might be missing some things. You might be maybe the device is not well grounded and it doesn't get enough power. So that could also be the reason why it's not working. But I don't know any specific website or platform whereby you can actually simulate a complete hardware project in like sensor. I mean, you could add all those sensor and just pretend as if it's printing out data. I mean, if anyone knows, feel free to share it within the group so we can learn together. Can you implement a backend? What is it for AWS or for the data itself? Yes. It's also part of the IoT. So I mentioned something called Node-RED. Node-RED is also like open source kind of backend. So it's like I would say, uh, it's a platform where, like a pipeline, basically. So I'm not going to share because our Node-RED, we also use Node-RED. It's an IP address. So that IP address, it's public. So like if I type it there, I can access the Node-RED directly from the website because we hosted it on AWS. But if you want to set up your own local host Node-RED, you can Google Node-RED. You see that you can create an entire pipeline of your IoT backend. So you could have input. So input is coming from a sensor, is pinging into a specific IP address, and is sending it to a dashboard. And the dashboard is also on a specific IP address. That could be maybe what you're saying about implementing a backend. So, but yeah. Um, so who else? I have one question for the competition. Oh yeah, so Chukwemeka, maybe Chukwemeka can take that.
All right. Yeah. So Lideti is asking, are we expected to make a hardware product? From my understanding, we're expected to work on a web app and an application. So I would say the expectation is that you build something that takes advantage or addresses the problem of resource constrained computing, right? It can be hardware, it can be software, it can be hardware and software, it can be any combination of technologies, right? So there's no restriction of technology. The main thing we're looking for in this challenge is people who are thinking beyond the, beyond the everyday kind of web app or mobile app that you can see, right? So if you're building a web app, that's great. But you know, the question I'll ask you is, how is that web app taking advantage of or addressing resource constrained computing or taking advantage of a resource constrained computing environment, right? So that's what you should be thinking about. Um, yeah.
Yeah. Okay. So that's done. So for Olabisi asked, is there any company specialized in yeah. I don't I don't know where maybe you're in Nigeria, but I'm not sure if you want to design like print something. There are different companies, probably they have their 3D machines, or I don't know if during the competition, Chukwemeka can kind of get you connected to some companies if you have to print something and they can do it for free. Um, I mean, during the competition also, I'm sure if someone got selected and they are into the project and they want to quickly fabricate something, I have printers as well. I can totally, if it's just a small batch of small, and you're sure of what you're designing and what you're printing, I don't want you to waste my filament. So I'm more than happy to help you print and find it shipped to you if you are part of the selected. Not like I'm just testing it. Yeah, so I'm more than happy to do that for a small batch. So, uh, how many AI assistant is allowed when developing a project that combine both hardware and software? So these are the things people have asked this severally. Even I have some, bachelor student I'm supervising at MIT. I think AI tools are really great. Engineering in general is hard. When I say it's hard, it's you cannot give ChatGPT to design your circuit, so it's impossible. They cannot do that. So you need to have some prior experience in designing your circuits. But if you're buying some modules and different things that they've already built, um, you can just potentially you can ask ChatGPT to write a firmware that you can put inside the code. But it will, some people now it's been better because if you know what you're asking, you can get everything printed out for you. But that won't scale. So you can imagine what we've created for the flatborn. There's no way we can ask ChatGPT to design the 3D model for us. What is it going to come up with? Nothing. So skills is still very important, but all this LLM is important for quick things if you want to get something modified for you. But you cannot get away from the fundamental knowledge of hardware, basic, and even software as well. So please don't. If you want to learn it, and let it be part of you forever. Because time will tell if you actually if you actually know it or not. So I remember, back in the days, it's not bragging because I wish I had access to computer really early in life. But by the time before I had computer, one of the things I usually do, my C language, I had to use. I learned most of it like just on the paper. I still have the book in my library because I cannot give it out. So I had a book on C programming. And again, it's not I can't advise anyone to write code on pen and paper because it's so difficult, but that was the first way I learned C programming. And eventually my parent was able to get me a computer. It was like I was in different heaven. So and I've been really good with writing ever since then. So yeah, you cannot take away what you learned, so you should find time to learn anything you have to learn. So Yusuf is back again. So he said, I'm currently building MVP for my project Echo Connect. I appreciate your input. Here's my setup. I have Raspberry Pi. Okay, good. I didn't know you had, yeah, I just mentioned Raspberry Pi, but I'm happy that you already have that. You have the microcontroller from Raspberry Pi as well. W6, which is maybe Ethernet connection, something like that. Yeah, future plan. Yeah, it's connected sensors for monitoring and automation. You're still using the monitoring and automation. So automation is you want to actually do some switching. So you want to turn on and off and all those things. Okay. I'm already implementing MCP for maybe MVP for online cloud side. The offline side is handled by Pi for lightweight and control. Okay. Yeah. Great. You're doing well. I don't know. That's not a question. Probably it's just sharing what he's working on.
I
Okay,
think
so
the
my
question he
question,
put the question at the bottom after that.
yeah, that's true. My question is, given that I already have MVP, is it MVP or MCP? I don't know what you, maybe you're saying MVP. It has its integration and rights wiring up and other. What would you consider a solid MVP? With a working demo that shows communication between RP and Raspberry Pi plus MCP enable agent handling be enough? Or should the MVP include sensing and real-time action? I think, yeah, you're mixing things. I don't know why you
No,
have to use the.
so
Oh,
just a clarification, he put something in chat. So MCP model context protocol. So I think maybe it's an AI. He's integrating with an LLM or something like that.
okay, okay. Um, would it work? Yeah, yeah, that's fine. I don't know what the RP2, why you're using RP 2040 with because Raspberry Pi created RP as a microcontroller. Why can't you connect the W6? I don't know what is that. Maybe it's like a module for socket. Yeah, why can't you connect that straight up with Raspberry Pi? Because Raspberry Pi already give you all the input and outputs that the RP 2040 is already giving you. RP 2040 was created by Raspberry Pi for very small, low cost microcontroller. If you have Raspberry Pi, you have almost 40 pins. Pick anyone and interface it with the W6. So unless if they are not in the same location or you're trying to create a small module for the W6 1000. So, um, but yeah, I think I'm more than happy to answer this also offline if you can kind of explain much more in details. Okay. So, yeah, I think the last one here, how to source materials to build a backend with Python. Well, I think depends. Like libraries are potentially probably open source for almost all the Python code, so you can always kind of get that. So sourcing materials for it, it depends on what you're building. If it's a research project or for the competition, just Google it and you can ask LLM what is the library for your backend or do yeah. So, but sourcing materials is just researching it basically. So yeah. Can we use simulation animations or render mockup to demonstrate parts that aren't physically built? For the composition,
Yes.
okay,
So, obviously the submit, and I think someone asked this in the chat as well, whether you're submitting online, which I can understand the question if you're building a hardware project. So yes, you submit online. For people who are building hardware projects, what we're interested in is want to see if possible, a working demo of the product through a video or something like that. And then any simulation, or if you can't have a working demo, then a simulation is great. And this is where your documentation becomes 10 times as critical, right? Because, that is how we actually know, the judges will actually know what you've done and that you actually, designed and built the
yeah,
project. So, yes.
yeah. Yeah, so I mentioned SparkFun during the conversation. So SparkFun, this is if you want to source components to build things really fast. I don't know if I think they deliver to Nigeria now. Uh, some of these components are cheap, some are expensive, but in order to get you going, I'm pretty sure you get some modules. And the way they design it is that you can imagine if your project has to do with optical sensing, what you need to do is there's a cable, you plug it here, the same cable you can plug it to your microcontroller, and you're good to go. So that's powerful. This is also like indoor air quality. They have the pins connected. This is a platform that you can get a prototyping out there like really fast. So which is SparkFun, and I'm pretty sure there are companies also in Nigeria. Probably they have some of the SparkFun components that you can kind of use to get your. Because the beauty of hardware is when it's work, when you can show it. Simulation might not really take all the like you cannot capture everything. So, but for the competition, as Chukwemeka said, maybe showing some of the information, the thought process alone it's a result. I keep telling you, I think we had a chat, me and Chukwemeka, some weeks ago. Um, One thing I've learned, and I had to relearn at MIT, is that the result it's not they're not interested in the result. The result is great if you're able to come up with results, but the process of you building that thing that eventually became a solution or a result, the process is really important. And this is you cannot do wuru wuru to the answer if you're Yoruba. Wuru wuru means you cannot just take. There's nothing like that. So show us how you decide to use these components. Have you tried some other components before? Have you tried to use, show us the process. I mean, the process will now show that you actually took time to do the research to pick these components, to put it together and decide you want to use it. So, and I think that's why MIT research publications are always like, it's like new things, new chipsets, new, yeah. So I think the process of building things it's already work on its own. So yeah. Okay, I think we've kind
Yeah.
of captured every question. So yeah.
Yeah. I have one last question before we
Okay. Is it your own question?
Yes, just
Okay.
one, just one. So and take as little time as you need. You don't need to make it a long answer. If you can just spend a minute or two to give us just the trailer version of your story, how you went from Ibadan to MIT lab.
Oh yeah. Yeah, it's okay. 1 minute. So yeah, I was born, I usually use because people always think I was born in the US, but really I was born in Ibadan. I had my bachelor's in Ogun State, actually. In fact, the course I study has been scrapped. So just so you know, by the governor back then. And then I moved to Rwanda to get my master's degree in Internet of Things and Embedded Computing System. I head back to Ibadan, where I came from after my master's degree. And then I was trying to look for PhD position in different places. I got hopefully I wanted to get into UC Berkeley. I had one of my mentor, but there's no funding. And I went to websites. I check out www.web.mit.edu. I just type Internet of Things, and it showed list of like research labs and projects. And I found a specific research where I am now. I applied like a PhD. I actually applied that I want to join as a PhD, but it doesn't work that way. I have to apply through the MIT system. But the director felt like, let's give this guy a chance. I had to present, did some exercise on different coding, whatever in the process, why I was still in the band. In fact, I had to put on some sort of like electricity when I was doing the video call because it was late. You can imagine the time zone with the US time zone. So eventually, it was a yes, and I moved to the US and to the lab. And, ever since then, I've been really contributing and kind of like being one of the core hardware and firmware and engineer within the lab. I have like a space, like a maker space where I build things. I'm always there alone, although sometimes people visit me when they're also bored. So and fortunately, the lab has they've been existing for like over 20 years. There's never been anyone try to come in from that part of the world. I'm the first person they've hired from African region, which is great. And fortunately, I also broke a record that no one has ever tried to like break a new record within the lab, which now people are beginning to now think of what else can they do to break record. It doesn't have to be Guinness, it could be inventing new things. So, and this is the vibe that we bring in as an African. So let's keep the vibe going. We always we rise and shine anywhere we go. So and we should always have the ability to relearn because I had to relearn a lot of things for the 4 6 months, meaning there is no wudu wudu to the answer. You show us the process, show us the steps. So yeah, pretty much that's my short version of the journey. So yeah.
Okay, thank you so much. Okay, maybe I'll sneak in one more, please.
Okay.
And that is, so you've given us how you got to MIT, which is awesome. How did you get started in IoT hardware, from Ibadan? Like,
Yeah.
yeah.
So I think my first experience in getting access to computer was I've said it in some of the article was in secondary school. The current governor of Oyo State wanted to be House of Rep. He finished from my secondary school. He donated computer, and that was the first time I actually touched a computer or work on it. And ever since then, I always want to do something with computer. I don't know if it's electronics or engineering, but during my bachelor's, because I studied telecommunication and electronics, so that time everyone wants to go to MTN, Glow, because telecommunication then was really like the core. But I had a course in electronics that has to do with circuit design. I felt like my dad, I don't know, they can't get me into telecom because you need to know people, you need to do all those things. But anyway, I decided to change everything. I said, I'm not going to go into like MTN or Glow or be a telecom engineer. So let me do something completely new. So my watchword then that I still keep using, I was telling some of my new like friends and families as well, is that which I'm going to share the watchword here, is that I wanted to create scarcity around my field. And I'm talking about 2011. It's not that long, but at least to me, it looks really long ago. I'm just 33. So I wanted to create scarcity around my field that time, and that was always the dream. I don't want to do what everyone else is doing. It's difficult to do to do electrical engineering or to do firmware. I'm going to do it. So, and now it's kind of easy because a lot of people are into that field. So after my bachelor's degree, I posted on Twitter that I'm creating a research site. Was it research lab? I posted it that I wanted to create a lab to build things. And then one of the first person that believed that this guy has something to offer was Femi Adeyemo, who is the current CEO of Energy. I think they've raised like $19 million. So I joined Energy. That was the first company I actually officially worked with Femi. I was there for 2 years. In fact, me and Femi traveled to China to bring in some of their first prototypes. And one of the things Femi said, if he's going to watch this again, it's very funny. He said, Toby, if this thing did not work, don't come back to Nigeria. Just stay in China. Because we got some Bank of Industry money. So Femi was the first person in my career, basically, that said, because posting saying I'm an embedded system engineer back then, it looks like it's only for people in the US, people in China. So, and when I posted that thing on Twitter, Femi felt like maybe this guy has something to offer, and then he eventually said yes, and then after Femi, I and that was the push that I had to hold on to this field really strongly and be courageous and kind of move on and do whatever I can do and learn and create. And over time, I got calls from Intel to be part of the innovator program. I'm still part of the innovator program till date. I've Intel gave me that platform to be able to travel to all the European countries to present and kind of showcase some of the Intel technology to use and get into some of the Intel tools as well. So and doing that also, I was also doing it in Nigeria, going for presentation, you know, talking on different TED Talk and all those things in Nigeria. So pretty much that's and I worked in another company called Rentsource for like a year before I moved for my master's degree, and immediately after my master's degree, while also in Nigeria, I try to do different startup, try to create new things, solar energy, or try to create yeah, and trying to create different projects within Nigeria that wasn't successful. But sometimes you have to try. Maybe startup is not my thing that time, but I've learned different things. I've learned in a very hard way. Um, so yeah, I think takeaway also is that whatever you're doing, either hardware or firmware. I mean, firmware most importantly, if you're writing software, before you can be an expert in it, you have to write it every day. So if you want to be an expert in firmware engineering, you cannot do it today and do it in 1 month. You have to do it every single day. So it's part of your day-to-day activity. So it should be like a prayer if you're a Christian or a Muslim or some whatever you're doing. So writing it or designing it should be every day-to-day activities. As you grow, you're calculating, you become like you can imagine someone posted a question here. And if my hands before even knowing what the guy is building, I knew for sure he needs to get Raspberry Pi, he needs to get this. And eventually he wrote something and say, oh, he has Raspberry Pi, he has this. So as you keep learning, keep building, keep writing every single day, you turn yourself to be an expert in that field. And and pretty much That's how my journey, kind of started and still going on. I'm still learning. I'm still reading. So yeah.
Wow. Thank you so much, Toby.
Yeah, I'm
For
really
me, that's
excited. So
probably
many.
even the most valuable part of this intro session, the inspiration that you've given us. So yeah, thank you everyone. Thank you, Toby, for joining.
Absolutely.
We're gonna share the recording. If you want to get the recording, make sure you're registered on the contest platform because that's where we're gonna share all this content. I put Toby's LinkedIn in there, so you
Yeah,
want to reach out to him with more questions on what you're building, so he can give you some input and stuff like that. You can do that
absolutely.
as well. And yeah, and also thank you to Fumi who has been in the background. You haven't seen her making sure that everything is working, working just great. Um, cool. Thank you so much, everyone, and follow us. Stay tuned. And yes, please connect with me as well on LinkedIn. I will share my chat, my profile in the chat. And feel free to continue the conversation. We have a Telegram channel for people who are in the competition where you can ask questions, logistic questions, even technical questions. If nobody has the answer in the community, we'll find people who have the answer and get the answer for you, right? That's the link to the Telegram channel. This is um, I put the link to my LinkedIn in the chat. I'm also gonna put a link to the ADTC um, LinkedIn as well, so that you can follow and continue to get updates. But yeah, I've popped it there in the chat. Thank you to everyone who has attended. We look forward to continue to engage with you and to see your awesome submissions. Just give it a shot. Whether you think, like the saying goes, whether you think you can or you think you can't, you're right. Right? So, just give it a shot. July 31st is the deadline. You can still do a lot. Even if you've already started, there's a lot you can do to improve your submission by that date. So yeah, just give it a shot. You never know. This could be your breakout moment. We're looking forward to seeing the awesome stuff you're working on. So thanks so much, Oluwatobi.
No
Thanks
problem.
everyone. And
Thanks.
we'll catch you on the next one.
Bye.
Bye-bye.